Some key features of Topspin strain include compatibility with a wide variety of TEM systems, an easy-to-use workflow that guides the user through data acquisition, automated alignments to assist proper setup of the TEM, and full integration between data acquisition and analysis. Because it is an external system, Topspin strain is compatible with a wide variety of TEM columns. The Topspin strain computer communicates with the Digistar electronics to control both precession and scanning. Diffraction patterns projected on the TEM's fluorescent screen are captured by an external high-speed camera. The Topspin strain acquisition workflow guides you through steps required to gather high-quality data. Ease of use is increased by dividing the entire process into smaller, manageable steps. Here we will show the initial setup of a Topspin strain experiment. First, the general area of interest is located in TEM mode. Initial alignment procedures are best performed with no sample under the beam, so the sample is moved out of the way. The probe is converged and centered. Topspin strain has 4 automated alignment procedures to ensure the best operating conditions: pivot point amplitude and phase, pivot point compensation, precession-induced offset correction, and pivot point height adjustment. We will illustrate these alignments. Starting with a converged probe, notice how the size decreases when precession is turned off. To obtain the best spatial resolution, the pivot points must be adjusted to minimize this effect. We will disable the red overlay to make the images more clear. The automated alignment adjusts both the amplitude and phase of the pivot points to minimize the probe size during precession. Observe how the increase in probe size when precession is turned on is now minimized. Distortions caused by precession are also corrected by an automated routine. We will zoom in on the display to make the effect more apparent. Notice how the overall probe size is optimized as the procedure continues. Offset in beam position caused by precession is also corrected automatically. Note how the beam moves when precession is turned on. And after the alignment, notice the offset is minimized. The pivot height adjustment sets the pivot points so that the precession occurs in the specimen plane. First, a line scan over a sharp feature is made with precession off. Then, the same line scan is acquired with precession on, and the pivot points are adjusted to make the two match. First, roughly size and position the desired acquisition area. We will set up for a 58 by 39 pixel map with 4 nanometer steps. During the series acquisition, the full diffraction pattern is captured at every position. A virtual stem image is also simultaneously formed, giving exact registration between the sample image and the diffraction pattern series. The Topspin strain analysis workflow has 5 tasks: conditioning setup, series conditioning, grain identification, strain calculation, and strain visualization. In the conditioning setup task, the mask to block out the transmitted beam is set up. Roughly position the mask circle over the transmitted beam. In the series conditioning task, first select the portion of the dataset for analysis. Then, the conditioning step sections off this data and applies the transmitted beam mask to the resulting data. The strain analysis algorithm can only calculate strain in areas with similar diffraction patterns. The threshold for this similarity is adjusted in the grain identification task. Strain will be mapped in the masked areas of the dataset. The motif structure used in the strain mapping algorithm can be fine-tuned in the strain calculation task. The spot markers can be moved to adjust the motif. The motif will be used to both correct geometric distortions in the diffraction patterns and to measure the strain. The resulting strain maps can be inspected in the strain display task. Linked profiles can be generated for the XX, YY, and XY strain components for quick comparison. These profiles can be exported to an Excel-compatible format for more detailed inspection.